It is a continuation of the previous session, keeping in view what factors favor the three different mechanisms. Mechanisms are E1CB and E2. Keeping in view all the factors which favor the different mechanism, let us understand the following reactions which undergo what type of mechanism and what product is obtained. Let us take one by one. The first example is this. Look at this example. This is the reactant and this is the reactant. Haloalkane and base. And the haloalkane type tertiary carbon, that is carbon is tertiary carbon. Need to understand what type of carbon is this and what type of alate present. Is a better leaving group, Br, that is a type. And the base is strong base. And look at that, the factors favor this and this and this. Here E1 means a weak base is required, but is not weak base. Here only it is E1 is not possible. And look at this, verify with E1CB. E1CB means this is okay, tertiary carbon, but Br is a better leaving group, not F or Cl. Therefore, E1CB is not possible, even though the base is strong. Here, this mechanism is not possible because of Br, which is a good leaving group. On that basis, it is not possible. And let us take the nucleophilic substitution. SN1, SN2. The base is strong, but it is non-aqueous, alcoholic. Therefore, so this SN1 and SN2 is not the mechanism which cannot follow this. And final option is E2 mechanism. What is the E2 mechanism? A strong base is there, that is alcoholic base. Alcoholic base and this oxide O. And this is the one on the basis we can follow this mechanism. What is the mechanism? E2 mechanism. This reaction follows E2 mechanism. So this base can act on, what is that? Look at this, this carbon is alpha carbon. There are 3 beta carbons. This also there, this also adjacent. So all our hydrogens are same. So this can attack any one of the hydrogen. Both are same reactions. So this hydrogen can attack and removes HBr, alkene formation. This is alkene formation. And the double bond here or here, no matter, same type of reaction. E2 mechanism, this is the reaction. This is all based on the factors which favor in different mechanism. On that basis, we are selecting the mechanism is E2 mechanism, the product is this. And the second one, look at this. The compound is, what is that? Written only C, that is CH3 is there. Hydrogen is not mentioned. It must be CH2 because 2 bonds, 3 bonds are already CH and CH3. Both molecules are same. And these molecules, if you use different bases, that is alcoholic KOH and what is alcoholic alkoxide, alcoholic KOH. If alcoholic KOH is there, is usually E2 mechanism it follows. And here alcoholic, that is alkoxide, what is the type of base? Very strong base, like this, even stronger than this. That is CH3, CO, tertiary butoxide, tertiary butyl alcohol, that is alcoholic tertiary butoxide. So this is also alcoholic, will follow E2 mechanism. So E2 mechanism will not depend on 3 and Br, any Cl, either any halogen or any type of hydrogen, but it depends on the what type of base, strong base, alcoholic or aprotic, that is alcoholic base. Here the difference, if you use alcoholic KOH, you get these two products, the major, minor. If you use this, that is strong base, this is small base, this is big base, there is a large base molecule. We get these two products, this is a major product, minor. Here reverses. This becomes major, this becomes minor. Here major, minor. Why? What is the reason? This carbon is alpha carbon. This carbon is beta, this carbon is beta. Here 3 hydrogen atoms are there, here 2 hydrogen atoms and CH3. So this carbon HCH3, this carbon contains all HH, small atoms. Here CH3, big group. Here this carbon is crowded, that is, there is a steric hindrance. Here there is no steric hindrance. But alcoholic KOH means -OH is a small base. It can act on this hydrogen, any one of the hydrogen, even though it is crowded, a small OH minus. So the product is this, if you act in this. So major product. And also there is small amount is also possible because of this acting on this also possible. It is a minor product. So if this OH is acting on this hydrogen, we get this. If this OH acting on this hydrogen, we get this. This is a major. This is minor. So this major and minor. This alkene is more stable. This alkene is less stable. But the product obtained during the reaction is a major product, minor product. Usually this compound is called as Seidzer product. The stable alkene is called as Seidzer product. And less stable alkane is called as Hofmann product. You know on what basis? Already in the last class I told you. Seidzer product is a stable compound. Hofmann product is a less stable compound. So by this reaction you get these two isomers, major and minor. Now if the base is this, look at the base is more crowded, that is more steric, that is CH3, that is steric, is a bulky group, contains a large base. So here no bulky group, here bulky group is there, CH3CH. This carbon produces more hindrance by the attack by this. But this carbon will not produce hindrance by the attack of this molecule. Therefore, it can attack the carbon, hydrogen of this carbon more probably than this. Therefore, it produces the compound like this as a major product, but produces this compound as a minor product. The reason here, this attack this hydrogen rather than this. Therefore, major, even though it is less stable major product, it is more stable minor product. So minor product. So E2 mechanism, both are E2 mechanism. So these are the possibilities. It is only the same haloalkane but different bases. The bases different is small molecule of base and there is a big molecule of base. It is alcoholic. That is the only difference. So you use this, what is that? Both are E2 mechanism but products are different. Major and which is major, which is minor. It is on the basis of selectivity. Next example is this example. Look at this carbon. This is alpha carbon. This is a beta carbon. This contains F. This contains hydrogen. Okay, no? And look at this. It is a poor leaving group. Look at this carbon. It is a electron withdrawing group. NO2 nitro group. I told you this is the one because factors favoring this. Both are here only. Here poor leaving group, this carbon contains electron withdrawing group. So this is more acidic. Therefore, on strong base, that is alcoholic base, very strong base. So it undergoes E1CB mechanism. First removal of this hydrogen and removal of this. forming this. Here the double bond formation. It is R, it is an organic group, of course. So another was E1C mechanism. E1C mechanism. So this is conjugate base. Okay. And look at this example. Carbon, carbon. This is alpha carbon, this is beta carbon, because beta carbon is carbon containing hydrogen, alpha containing F. There are three, of course, F. Again, looking at this point, this is a poor living group, any one of them. And carbon with Cl, electron withdrawing group, inductive effect, minus inductive effect. This will stabilize this anion formation, this becomes more acidic. So looking at this group and this group, one can decide what mechanism it can able to follow, E1CB mechanism. So strong base is there. This is very strong base. First H plus removal, that is CB formation, conjugate base. Then this is removed, forming a double bond at this point. This is a compound formation, minus HF. E1CB mechanism. That is the fourth example. And the fifth example, look at this, already alkene is there. Here Br, CH3. And a strong base is applied. Very interesting point is this, double bond. This carbon, that is alpha carbon, beta carbon. Alpha containing halogen, beta containing hydrogen. If double bond is there, usually double bond is like an electron withdrawing group. Presence of pi bond is electron withdrawing group. The presence of pi bond makes this hydrogen more acidic. Even though Br is a good living, better living group, this is more acidic because of this. And action of this base is very strong base. So undergo E1CB mechanism. Usually alkenes undergo alkynyl halide undergo, that is elimination gives alkyne formation. So these are eliminated. First this is a removed as C minus formation. Then this is removed forming. That is double bond become triple bond. Pi bond, two pi bonds, one sigma bond. So E1CB mechanism. So all usually alkynyl halide undergo elimination in presence of strong base like this gives what is that corresponding alkyne. E1CB mechanism. And next is also same type, but here aliphatic, here aromatic. This reaction was so strong that even aromatic also undergo same type of reaction. Aromatic means if you take any one of the double bond is alkene like. Alkene like. If F is there and there must be another adjacent carbon hydrogen. This undergoes same type of reaction as this. Strong base, and this H is removed as H plus, and later F is removed as M minus. So double bond becomes triple bond. That is benzene derivative becomes benzene derivative. Benzene. That is one of them is triple bond, remaining two double bonds alternate. Of course, it is called as benzene. It is E1CB mechanism. These both are same like this. So a strong base acting on alkene like this, even in benzene, even though it's unreactive, that is not less reactive, it can undergo reaction, this elimination reaction like this to give benzene formation. That is called benzene, this is benzene, the difference. And in the next example, look at this, this strong base, very strong base usually, sodamide, NH2 minus in ammonia, very strong base. Look at this carbon, these two carbon are in alpha carbon, beta carbon. Hydrogen and fluorine is a poor living group, and this carbon is contained, what is that, bonded with benzene. Benzene is itself is a strong withdrawing group, and also NO2. In addition to this, two NO2 is there, strong withdrawing groups are there. So overall, it's a very strong withdrawing group, electron withdrawing group. Therefore, it is more acidic. Undergo E1CB mechanism. That is, this is the intermediate formation. Then F minus use double bond here. E1CB mechanism. Product is this is the mechanism it follows. And the next one, here CH3, CH, there are two hydrogen, CH is there, it's known. That is CHF. Here CH3, three hydrogen atoms are there, but only one hydrogen is. Because this is alpha carbon. Again this symbol CH3, CH2, one hydrogen is shown. Here CH, this hydrogen is not shown. F, CH3, two hydrogen are not shown. One hydrogen is shown. This is alpha carbon. This is beta carbon. This also is beta carbon, adjacent carbon atom. This is beta hydrogen, beta hydrogen. By the action of again a large base molecule like this, similar to that deuteroxide, tertiary deuteroxide, large base molecule. Here E1CB mechanism undergoes, no doubt about it. That is poor leaving, because it contains poor leaving group. Then if that is the case, this base attacks which hydrogen? This hydrogen or this hydrogen? Look at this hydrogen, this hydrogen, hydrogen. This is less crowded. Here one more hydrogen, this is CH3, this is more crowded. This base molecule is also more crowded. O minus, more crowded. More crowd cannot attack the more crowd because steric hindrance. There is a bulky group which prevent the approach of this to this carbon. But here not bulky, H small hydrogen atoms. So it can attack this hydrogen, remove this hydrogen, and then later forming a pi bond here. Here, pi bond here. The product is Hofmann product. ECB mechanism. So actually, if small base is there, it can attack this. It can form a bond like this. That is Setzer product. But you get in this, with this base, we get Hofmann product like this. This is a alkene formation or pi bond formation occur here, eliminating this. Not eliminating this, no pi bond formation here. The product is Hofmann product. And the last one, look at this carbon. Carbon with this is, that is ethyl group and methyl group. This is of course secondary carbon with Br, a strong leaving group. Br is strong leaving group and contains action of base, very strong base, methoxide. And this strong base in here Br, because of Br, you will never undergo this kind of mechanism, E1CB. Strong base and alcoholic ethanol can undergo only E2 mechanism. The possible is E2 mechanism. That is, this hydrogen and this Br is put, forming a double bond here, like this. E2 mechanism usually give the Setzer product. That is in this case, This is the alkene formation. Follow E2 mechanism, not E1CB mechanism. It is based on this Br. Br is a very better leaving group and very strong base like this, alcoholic base, undergo only E2 mechanism, not E1CB. So just on the basis of the factors that is written over there in the previous class, we can understand, that is, any example like this, what mechanism they can follow and what is the final product of this reaction.